Hi students, this is the second lecture series on the subject Digital System Testing and Testable Design, Module 2, Part 2. I am Seema Safar, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. In this session, we'll be discussing on the topics single stuck faults and multiple stuck faults. Let's begin the session. Single stuck faults. It is the most common model used for logic faults. There are three properties which define a single stuck fault. Only one line is fault. The faulty line is permanently set to 0 or 1. The fault can be at an input or output of a gate. These are the three properties which define an SSF model. Suppose that we have a fault on a line A. In that case, it can be either stuck at logic value 0 or it can be stuck at logic value 1. Now this can be denoted like this. If you have a logic value stuck at 0 on a line A, it will be denoted as S hyphen A hyphen 0 or S by 0. Now the logic value is stuck at 1 on a line A, it can be denoted like this. These are the two ways in which you can represent the stuck values. Now consider a circuit shown in the figure. This will be representing the test vector that is being fed into the system. And here you can see a stuck at 0 line. Now this is the line which is stuck at a logic value 0. So it will be outputting only 0 because it is stuck at logic value 0. Now since it is an AND gate, when 1 and 1 happens to be going inside as an input, we'll be getting 1 as the output. That will be the correct response. But since this is stuck at 0, it gets converted to 0. Alright, now this error is propagated here. Now the response of the circuit can be, if it was a fault-free response, it would have outputted a 1. But since here we have a stuck at 0 logic or a stuck at fault, now the response is a faulty response and therefore the response is 0. Hope you understood what is a single stuck fault. Now, a fan-out stems and fan-out branches are considered as separate lines in SSF or single stuck faults. Consider the circuit that is shown in the figure. Now this is going to be an AND gate and you have two inputs and an output, and we have a fan-out here, fan-out branches. Then in this case, since in SSF model fan-out stems and fan-out branches are considered as separate lines, we'll be having a fan-out of with 1, 2 and 3. So for a circuit with K lines, total number of single stuck at fault is 2K. Alright. So this is an important point that you should note when you are dealing with single stuck fault model. Now let's work on an example of single stuck fault models. Consider this circuit and you are asked to find how many single stuck fault for this particular circuit. We have studied from the previous slide that for a line K, you'll be having 2K single stuck fault, right? So here, what will be the value of K? Let's count on the fan out. 1, 2, 3, 4, 5, 6. Why? Because fan out stems and fan out branches are considered as separate lines in SSFs. Now 7, 8, 9, 10, 11 and finally 12. So here we have k equal to 12, therefore number of SSF is equal to 2 times 12, which is equal to 24. So the answer for this question is we'll be having 24 single stuck faults in this circuit. Now this is an XOR gate using NAND gates. Now let's discuss on the last topic of this module, multiple stuck fault models. A multiple stuck at fault means that any set of lines is stuck at some combination of 0, 1 values. So in this case, any number of circuit lines can have stuck at fault at any given time. It's not just a single stuck at fault, but we'll be having multiple stuck at fault. So for a circuit with k lines, the total number of multiple stuck at fault is 3 raised to k minus 1. So how many multiple stuck at fault for this particular circuit? Since the value of k is equal to 12 here, we can say that it is 3 to the power 12 minus 1, which is probably a very large number. And that is the reason why the use of a multiple stuck fault model is very rare, and the most commonly used model is SSF or single stuck fault. So that is the end of this lecture session. The reference textbook for this session is listed here. Thank you.